This circuit board is of an indoor mini split air conditioner. This is a non-inverter air conditioner circuit. The blower motor is working on this circuit board. The display is also turning on, but this circuit board cannot start the outdoor unit fan and compressor. The problem could be in the circuit board if the outdoor unit does not start, because in non-inverter air conditioners, the indoor circuit board controls everything. The outdoor has a compressor, fan, and some capacitors. The relay is not passing the output. I am testing it with the tester. This circuit board has been powered on for quite a while, but its relay is not passing the output. The tester light glows when I place it on the relay's common pin. It wouldn't be visible because of excess lighting, but the electricity passes through on the relay common pin. Let's find out if the relay or the circuit board is faulty. First of all, I will check this switching relay to see whether it is bad or not. If this relay is bad, it will not work. Let me explain how it works and what its function is on the circuit board. The switching relay sign is made on the back of the circuit board. This point is the common point of this relay. This is the switching point. The point from the right joins with the point on the left. This is how the compressor installed in the outdoor unit starts to work. A coil is installed inside the relay between these points. This coil produces magnetism, which is why the points on the other side work and are joined together. Now, I will check the internal coil of the relay, because if they go bad, the relay will still not work. The mechanism in the relay goes bad. Still, it will not work. A diode is installed here. I will check this diode with the coil. I am checking the coil on ohm mode. It shows a 171 ohms resistance value on the multimeter. This means the coil of the relay is fine. Other than this, let's check this diode as well. I have placed the probes on the diode. The voltage drop of the diode is 0.165 volts. The voltage drop is less as it is installed between the coils of the relay. It is installed to prevent the short circuit. In the case of a short circuit, the Zener diode will open the circuit, and this circuit board will not work. The Zener diode is okay. I will pass electricity through the circuit board to check the voltages on the relay. To make the work easy, I have installed 2 pins on the coil's pin. This will make it easier to attach the probes to these pins. I will set the multimeter to DC voltages. I have attached both the multimeter probes. Now, I will power the circuit board. The electricity is passing through the circuit board. Now, I will have to wait for it to start functioning. The fan motor has also started to operate. I will have to wait.
5 minutes later.
It is almost 5 minutes, but the relay is not turned on. This means the circuit board is not passing 12 volts to this relay. This means the microcontroller or the ULN 2003 IC could be bad. So, I will start testing it. Let's remove this ULN 2003 Darlington IC from the circuit board and replace it with a new one. I will heat the IC with the heat gun. The IC has been removed from the pads. I will put some paste on the pads, and clean the pins that are joining together. Then, I will solder the new IC. I have soldered the new IC with the pads. Let's check whether 12 volts pass through the relay. I have powered the circuit board by passing electricity through it. The display of the circuit board is working. The blower motor has also started to operate.
5 minutes later.
It's almost 5 minutes again, and the 12 volts are still not passing through the circuit board. I will now check whether the voltages pass between the microcontroller and the Darlington array. Most of the time, I have seen that the Darlington array goes bad if the 12 volts do not pass through the circuit board. I have removed the switching relay from the circuit board. It is not functioning well electrically. The coil resistance value is absolutely okay. I have another relay, and the resistance values on both relays are the same. The switching of this relay is weak. The internal mechanism, due to overheating, has gone bad. This new relay is working fine. The problem is that 12 volts are not passing through the relay. The relay is not faulty. The voltages from the microcontroller pass toward the Darlington array to make this point negative, and moves toward the relay. The left is positive and the right is negative. To pass 12 volts through these coils, the pin number 1 and the pin number 16 are joined together. When 5 volts pass through pin number 1, the pin number 16 is open. The relay gets the ground from this pin of the Darlington array. This is how the coil gets the 12 volts. Let's check if 5 volts are passing through it or not. The circuit board has been powered on for quite a while. I will check the voltages on the Darlington array. The 8-number pin is the ground pin of this Darlington array. The 6, 7, and 8 pins in this circuit board are joined together. By the way, they are separate pins but located in the same place in this circuit board. The resistor number 68 is attached to this pin. No voltages are present on this pin as well. I will wait a little more. What if the voltages start to pass? I will check the voltages with the ground pin of the Darlington and the relay coil. 12 volts are passed through this pin, which means the ground pin is fine. This means the microcontroller is not able to turn on the voltages, which is why the relay is not turning on. So this circuit board can't be fixed. I am tired now, and I run on coffee. So buy it for me on Patreon. Click the link on the screen to visit. Click on the left or right thumbnail to watch our next videos. And subscribe. Thank you.